Hey, what? We're going to move on to talking about derivatives of our log functions. Uh, we're going to relate derivatives log functions to derivatives y equals e to the x. And again, y equals e to the x is that special function, just the right function where the slope of y equals e to the x is always equal to the y value, which is e to the x. The other thing that we want to remember is that if you have y equals natural log of x, that's the same thing as saying log of x to the base e. We don't write it this way, but it's a nice way to see it as you're kind of learning about natural logarithms. Just remember your base is e. And again, because we want to talk about something new, we're going to relate something new to something old. So again, if you change this to an exponential function, your base is e and y is the exponent. So you have e to the y equals x. So we're going to talk about finding the derivative of y equals natural log of x by talking about the derivative of e to the y equals x. And again, what we learned in our previous lesson about derivatives, if you have a function that's e to anything, the derivative starts with just repeat e to then anything. And then the chain rule says you take the derivative of whatever your exponent is. So I'm going to take the derivative of the y value. And then what's the derivative of x? The derivative of x is 1. So if you do a little bit of math, a little bit of rearranging here, I want to solve for the dy dx. Then it becomes 1 divided by e to the y. So the slope function is 1 over e to the y. And we knew from the start that e to the y is x. So the derivative of our original function becomes 1 over x. So how does that relate then to what we're talking about? Remember, we said we really wanted to start off with y equals natural log of x. And because these two statements are the same, then this derivative will also be 1 over x. So if you have y equals the natural log of x, its derivative is 1 over x. Or in terms of a function, again, we could put all kinds of functions in here, natural log of a sine function, natural log of a polynomial function, natural log of a rational function. The first step you do then is whatever this function is, it's the reciprocal, and then the chain rule always kicks in. That's where the layers come in. You take the derivative of whatever else you have inside your brackets. So again, the rule itself for taking derivatives of natural logs, the same as the rule itself for taking derivative of y equals e to the x. That rule is actually a fairly simple rule, and that kind of catches us sometimes when the questions seem too easy. So what we always do is we always layer these questions with other skills. So our examples, we've got a product rule. Function is f is x squared. Function of g is natural log of x. F prime g prime. Put it in, simplify. And again, lots of what you're going to see, lots of exponent skills. X squared over x is x. Common factoring skills. And those things are going to be key for us simplifying all the way through. For b, I've got y equals natural log of x squared plus 1. So again, the very first layer is it's the reciprocal of x squared plus 1. That's the first layer. Second layer, what's the derivative of x squared plus 1? That's 2x. All right, so there's your layer in that question. C, you have a function that's being cubed. This is not x cubed. This is log of x times log of x times log of x, or natural log times natural logs times natural log. So the chain rule says the 3 goes in front and the function is now squared. And then what's the derivative of the function? What's the derivative of natural log of x? So you get 3 times the natural log of x squared, and then derivative of natural log of x is just 1 over x. So that's that layer. Product rule. The first function is x. The second function is natural log of x. F prime g prime. Put them together. Put them into your formula. Again, you've got some rules happening here where you have x times 1 over x is 1. So that's kind of what we do with our natural log differentiation. We apply the rule, which is simply whatever the function is, it's the reciprocal of the function times by the derivative of the function. So B probably is the best example of what we're talking about. Reciprocal of the function times by the derivative of the function.